Welcome, this is Dora, and today I will show you how to create a structure mesh in Salome. And we will be creating a pipe and create the structure mesh for this. Okay, first I will use this shaper module. So click this shaper, and now we are inside shaper. And we will create a pipe, so it will be a cylinder. So before doing anything, we will click this part and new part. I'm using Salome 9.9.0. If you are using later versions like 9.12.0 or 9.13.0, you don't need to do this new part thing, and the part 1 will be already there. But in Salome 9.9, you need to create this. So now we have this part 1, and I can see the coordinates. So I will create a cylinder. So here you can click this or build primitive cylinder. Okay, and here on the left side we can set the origin and of this cylinder, and we can set the diameter. So the units are Salome is basically unitless, but I will assume these as meters. So it would be 0.1 meters long length, and I will do like 1 meters in x direction. So I want my pipes in x direction. So you click this vector and click this x axis. Okay, and to see the pipe, first you want to click this interaction style switch. So if you click on this, you can easily rotate the screen by dragging, and you can pan by dragging the middle mouse button. And now I will click this fit all button, and you can also do this global panning, but fit all. Now we can see the pipe. Okay. Sorry, I have a cold, so I'm sorry. And before we do anything, I will rotate the pipe a little bit. Okay, I will create the middle part. So the plan is like this. Here we will create this cylinder, and we will create this middle rectangular pattern region, and slice the region to make this structure mesh in this format. And after that, we will divide the domain in each region, sub-region, whatever you call, by giving the number of mesh points in each edge. So we want to create this rectangle region first. If you do not understand at this moment, you don't need to worry. Just follow me and you will be fine. Okay, so I will create this rectangular region on this face, and to create this I will create a sketch. So sketch, and click the sketch, and we need to give a plane to draw our sketch. So the shaper module is here's how the shaper module works. We create the sketch, and we can extrude or rotate or something to generate the 3D model. So I will choose this face as a base plane for our sketch. So to create our rectangle, I will click this rectangle, and okay, now we have our rectangle. So I have when given the dimensions for this rectangle, and if I right click on this cylinder and edit, I can see the diameter. I think this is the radius. Radius is 0.1. Yeah, it's radius. So maybe this is like, I will do 0.02, maybe 0.02. Okay, and I will give the dimension. So if you want to change something inside this anything, you just click this here, not inside the results but under the results, below the results. You have these intermediate steps, so you can right click and edit. In this way we can edit our intermediate steps. Okay, so I will give the dimensions for each sides of the rectangle. So horizontal, here, okay, and 0.025. Cool. And here another 0.025. And now the rest are vertical. Oops. I think here. Okay, 0.025, and the last one here is 0.025. Now our rectangle is green. It means all the degree of freedoms are solved. So we can we should not modify anymore. We should not add any more degree of freedom. It will over constrain the sketch. Now we are ready, and I will extrude this rectangle. So click this here in extrusion, and you can also find this in features. Extrusion is the same, and you want to like choose this one, face wires, to create a solid. So if you choose this middle one, you will be creating a surface. So I will want to this the rightmost part, and now click this construction sketch one. Okay, now we extruded in this negative x direction. So I don't want this, so I will give this 0, and I want 1, the length of 1 in positive x direction. So here, okay, now we have this 2 objects in the results. So if you hide the cylinder, we have our rectangle. So but these are separate objects, and I want to create this guy. So to create this, we need to create subregions in having 4 sides, each of them having 4 sides. Okay, to do this, I will create a combined regions between this cylinder and extrusion, and I will use this smash. Okay, click the smash, and the main objects should be cylinder. Okay, and the tool object should be extrusion. Okay, and then click apply. Now we have a combined object. Now you can see here smash, and here okay, now the cylinder part is it has a rectangle, and it has a hollow, which is rectangle, which can be filled by this rectangle. So we will slice this like this direction: 1 side, 2 side, 3, 4 sides. So the final goal is to make these 4 external subregions. So I will slide this with planes. So if you want to slice something, you need a plane. But before slicing, I now notice that I made a small mistake. So I will remove the smash, just delete it, and now we are back into the 2 separate objects. So before doing the extrusion, I needed to rotate this cylinder. Why? Because there is an edge here, and it will give you trouble when you slice it and when you create the hexahedral mesh. So I want to rotate this cylinder in X direction by 45 degrees, and let's do this. So it's part and translation. Okay, so not extrusion. The main object should be a cylinder or cylinder. Okay, and the vector is our x-axis, and no, I want to rotate. No, I think not translation, and rotation, sorry. Main object is cylinder and vector is this x-axis. Vector is in x-axis. Okay, and 45 degrees, I think. Okay, any 45 is fine. Plus 45, negative 45. So here it's rotate by 45. So if you slice now, it will not create another edge. Otherwise, it will have this edge will remain, and the slicing process will create another edge, which will conflict the hexahedral mesh. So sometimes you need this work, but sometimes it doesn't. So I will do the smash again. Now smash, and main object is a rotation. Now it's not cylinder anymore. Okay, and the tool object is extrusion, and click OK. So far so good. Okay, cool. So I will, by the way, I will save the file in somewhere. Salome tutorials, pipe structure live. Okay, now I will slice this. To slice this we need to create a plane. So say I want this direction and this plane, so we need two planes. And to create a plane, you need to, here it is a construction and plane. Click plane, and it will ask you to create a plane by another plane, by other plane, and you can choose existing plane as a base plane and rotate it or move it. Okay, but I want 45 degree plane, so I will choose this. So this plane is x plane, so it should be in here somewhere in construction. So XOZ, the plane is XOZ, because I want to rotate this plane. And okay, I rotate, and then the vector is x direction, because I want my plane to rotate 45 degrees in x direction, and number of copies 1. Apply, and I will create another one. Build, not construction. The base plane XOZ and x direction, and this is 135 degrees. So we have these two cross planes. Okay, now I will hide these two planes and fit all. And if you unhide these planes, you can see here it will divide our cylinder into 4 nice pieces. So let's slice. It's called split in Shaper. So click split, and the main object is this smash 1. Okay, and the two objects are plane 1 and plane 2. You can shift click to select both of them and click apply. Now we have our sliced object. Okay, so we have these little 4 external pieces and 1 internal piece. So you can see here each piece has 4 edges in every face. 1 2 3 4, 1 2 3 4, and in every direction 1 2 3 4. We can create the structure mesh. Save it, and we will go to the meshing part. Mesh, and in the object browser we have this split one. Right click it and click show, and then similar to the shaper module, I will turn on direction style and click the fiddle. Now this is the object. It's not very easy to see, but our object. So what do I do is click this split one and click the mesh in the menu bar and create mesh. Okay, and I'm going to create a 3D mesh. So here, hexahedron. So for the algorithm you need hexahedron, and for the 2D algorithm you need quadrangle mapping, and for the 1D you need something called wire discretization, and we need to give the number of segments here. So I will give 15, which is default. Close. So let's see whether it can create a nice structure mesh. Okay, now our structure mesh is obtained. It's good, but we haven't assigned. We cannot assign the number of cells in this direction, or this axial, radial, or this tangential directions. And to give these directions, we need to define the edges. We need to create groups of edges, and we need to give the number of edges, segments for each edge. So how should we do it? Click the features and group. Okay, and to group the edges, name group 1. So I don't know how to name it. So these are axial. So I will get n axial, and click this type as edge, and choose these one and press shift and 2 3 4. Okay, and then 1 2 3 4. Okay, and then you can click this apply and continue. So, and after that I will choose these circumferential and circumferential. Okay, and I will choose these edges here, 1 2 3 4, and 1 2 3 4. Okay, and click apply. Okay, so the rest is this length. Okay, and then I will give these 1 2 3 and 4. Cool. Okay, so here in the I can see the groups created are in red, and these inner sides have not created, so I forgot it. So I will add these again to n circum, and right click this below in the list and edit. Okay, now you can add more. So this, and so these are paired with these inside edges. So I will click these and oops, not this one. Okay, I think I'm fine. If you are not sure, you right click this and click show only, and you can see the only edges. And here, okay, I think I'm good. Okay, let's save it and go back to the mesh. Here, I already have these edges, and so what I will do is create a submesh. Right click the mesh I just created and click submesh. And for the geometry, I will click an axial. Okay, so it will only enable 1D, and I will choose wire discretization, and I will create a new number of segments. So you can give the name to your hypothesis. These are called hypotheses. Anyway, these will define the element number, and axial. I will give an easy number, an axial, and apply. Apply close. Okay, so I have a submesh. Now you can right click. You can rename. Okay, and axial. I gave everything the same name, so it's much less confusing. Edit submesh, and if you want to change the number of elements in axial direction, you can change it here. 15 instead of 15, you can go 20. And I will add another submesh, which is for the end subcom, and I add wire discretization and number of segments and subcom. Okay, now I will keep these numbers the same, but I will change again after that and create submesh, and this time the last one, the end length. Okay, now wire discretization and number of segments. Okay, and okay, now if you here it shows we need remeshing, and it will not change anything because I haven't changed the setting to from 15, and okay, I need to rename these, and subcom and length. Okay, so I would now I will change increase the number of cells in the length in this direction. So right click this and edit submesh, and in here which you can adjust this adjust button beside this pinion button. Now I will give 40, and okay. Oops, I think I forgot the inside length. Okay, anyway, let's see. Let's click the mesh and compute. Okay, now it complains something because now the number of cells on the face increase because it was before it was 15 and now it's 40. But the problem is inside I haven't included the inside, so I go back again to shaper and I will change this again. Sorry for that. Edit. Okay, I forgot to add the insides guys, so to do this I will show as a wireframe and then and edit, and I can add shift press shift and add 1 2 3 4. Okay, now I think it's fine, and I think I need to remesh. This is a bit complicated. I have to do this again. Click mesh and hex head quad 1D. Okay, so this is a base mesh, and I'll have to add the sub meshes again, it's not cool, but I have no choice. And wire discretization, axial, apply. Next one is circum, apply. The next and length, apply and close. Okay, I think I've done the submeshes, and now everything is fine. As you can see, the number of cells increase in this direction, so we can also play around with this and rename axial and circumferential, and okay, and you can, for example, increase the number of cells in axial direction from 15 to like 25. Okay, let's do 25. Click. Oops. Okay. Remesh. Now you can see here it's much finer, and you can also play around with this circumferential numbers. So it's 15 for now. You can go 20, and okay, I need to click this mesh again. Now it's much finer. Okay, and you can easily export this mesh for OpenFOAM or other CFD solvers, and this is how you can create structure mesh. Now the idea is to create blocks which has 4 edges, so it's hexahedra blocks. The technical name is hexahedra blocks, and if you can do this, you can easily create a structure hexahedra mesh in Salome. Thank you very much, and see you later. Bye bye.